Here it comes, solve for the zeros, where it crosses the x-axis. Solve the parabola, the pride of math class. Here it comes, the quadratic formula. Today in 9-5, we get to do the quadratic formula, and it is the surefire way to always be able to solve for the roots of a parabola. This formula is written right here where you can see it. And again, we're going to be looking at A, B, and C. And notice all the places it gets plugged in, like so. One thing that you might notice is that it does have to equal 0. So as I go to solve this, the first thing I'm going to do is make it equal 0 by just adding 20 to both sides. So now I have x squared minus 12x plus 20 equaling 0. And from there, I just literally plug it in. If it helps, I might write what A, B, and C equal. A would be 1 in this case. B would be this negative 12. And C is going to be 20. So if the formula says to do a negative B, that's actually going to be a double negative with a negative negative 12. Plus or minus the square root of B. I go ahead and put that in parentheses. Squared minus 4A, which is 1. C, which is 20. All over 2 times A is 1. Okay, so that is how you plug that in, and then you just solve. Start with what's underneath the radical sign. So negative 12 squared is 144. And I'm going to be subtracting the 4 times 1 times 20, which is 80, and that's going to be underneath the radical sign. If I want to go ahead and figure out what 144 minus 80 is, it is 64 underneath that square root. Actually, can I go ahead and just fix that double negative? That's going to be just a positive 12, plus or minus. 2 times 1 is 2. Now, the square root of 64, it is 8. Now, I know what you're thinking, Miss Barnum. Yesterday, or a day or two ago, you said, wrong, it's not just 8. That should be the positive or negative 8. Well, here's the cool thing about the quadratic formula. It took care of the fact that that can be positive or negative by having that plus or minus sign right there. So you can just say 8, move on with your life. But once you get to this step, you're going to go ahead and divide into 2 equations. Again, the same way we did yesterday, just dividing out that positive negative. And simplify. 12 plus 8 is 20, divided by 2 is 10. 12 minus 8 is 4, divided by 2 is 2. Those are your 2 answers. Now, here's the thing. I'm giving you the formula today. You will never be given the formula again. It's not going to be on your test. It's not going to be on an ACT, the state test. They're never going to give you the formula, so you have to memorize that. Now, the good news is I have an easy way for you to remember that, and it's by telling myself a little story. So there once upon a time was a negative boy who couldn't decide if he wanted to go to this totally radical party, man. Now, they say it's B there or B squared. By the way, do you know why they say that? Because if you're not there, you're not around, like a circle, right? All right, so it's B squared. B there or B squared. He didn't go, so he missed out on 4 awesome cupcakes. The party got over at 2 a.m. And what do you see there? That's the formula. So, just so you know, if you end up with a negative number underneath the square root sign, you're going to end up having no solution. Let's think about that for a second. Well, actually, here, pause. We have 5 methods to use to solve for the zeros of a quadratic. Factoring was actually what you did back in Chapter 8. You just didn't realize that that's what you were doing. Graphing, we did that in 9.1, 9.2. Using square roots, completing the square. Both of those were covered in 9.4. And then now the quadratic formula. So, sometimes all we really want to know is how many solutions there are. We don't really care what they are. Sometimes we only care about how many there are. So we're going to use something called the discriminant. The discriminant is only the stuff that's underneath the radical sign of the quadratic formula. So the b there, or b squared, missing out on 4 awesome cupcakes. That is the discriminant. So think about this. If you plug that in and you end up with a positive number, remember that that's underneath a square root sign. So if you end up with a positive number underneath a square root sign, you could have either the positive or the negative of that. Like the 64. You could have had square root of 64 was either a positive 8 or a negative 8. And then that allowed us to split that into 2 equations and gave us 2 answers. So that's the situation. If your discriminant is positive, you will have 2 solutions, or 2 x-intercepts. Now let's say that you do b squared minus 4ac and you get a 0. Well, the square root of 0 is 0. Not positive 0, negative 0. It's just plain boring 0, which means that you can't really divide it into 2 equations. And if you do, you're just going to get the same answer. So if your discriminant equals 0, then it's going to have one x-intercept, and it's going to be at the vertex. Right there, right? Last but not least, let's say you do your b squared minus 4ac and you get a negative number. Well, if you get a negative number, you can't find the square root of a negative number, and so that's where it's going to be no solution. If your discriminant is negative, there are no real solutions, so it would be negative. All right, so let's